I work for Panzura. I'm a senior product manager here. And today we're going to talk about achieving seamless cross-site CAD collaboration and BIM collaboration using Panzura. So some of the things we're going to cover today are why BIM and CAD applications do not effectively work across distributed sites. Most AEC companies, or a lot of them, are distributed. It's an industry that's inherently very distributed in that they generally have, larger companies have offices in every large city. And for a while now it's become a problem where they want to be, have multiple people in different cities, but you want to leverage the best people you can. And therefore you need to be able to share the data you're all working on in a fast, efficient manner. So we're going to talk about how you can do that. We're going to talk about some of the solutions that have been tried prior to Panzura, some things like bandwidth and why increasing your bandwidth doesn't just solve your problem, latency and how latency can affect things like file locking and using CAD systems. Really, I'm just going to cover bandwidth and latency at a real high level. It'll be fairly quick and will not have a huge, don't get too worried that it's too technical. I do want to explain those concepts though and how they affect what you're going to be doing if you work in a global environment, and how file and open and sync times can be significantly reduced with our solution. So, why am I not going to my next slide? There we go. At a glance, this is Panzura. I show this slide simply because we do a lot of work with AEC companies, but we also, our solution is a whole office solution. It's about all your data. It's not just an AEC solution. It's not just one product. It's about supporting all your products and getting all that data to be leveraging the cloud for all that data. And so you can see some of these firms are AEC firms, some are manufacturing, some are software development. We market heavily to the AEC industry though because we solve their problems so much better than almost all other industries. Today we have 15 plus petabytes of data in the cloud, meaning people reading and writing to the cloud and leveraging the cloud are using a lot of our controllers. 1,600 controllers is a little out of date. It's actually well above 2,000 now. So Panzura as a solution can actually, this kind of sums it up. What we do is we have a very simple setup. We have a device we put in every one of your offices, and that device is basically a gateway to the cloud. It makes the connection to the cloud very simple. So you go up to whichever cloud provider you want. We don't dictate who you use. You can use Amazon, Microsoft, Google, all the big name clouds, and you create an account up there, and then you just plug that information into our device sitting there in your office, and we handle everything from there on out. We handle the tunnel to the cloud, we handle encrypting your data, securing it. Our device looks like a share on your network, and you're just reading and writing data to it, and we're handling everything after that. So the reason it's a great solution even for one office is because we have a small device in your office that caches the data you're reading and writing at that time. The cloud behind you can be as large as you want. You have unlimited capacity. You don't have to worry about continuously buying more drive space, drives that fail, things like that. It's all up in the cloud. It's all protected. And you only pay for it as you use it. You don't have to buy it up front hoping you're going to use it. You don't have to worry about backup, archive, data recovery. The cloud is so stable and secure. They have multiple levels of redundancy that all of those issues and concerns kind of go away. Our product works with your Active Directory that you already have, so if you're setting permissions for who can see what on these drives, you continue to do that, and you just set the Active Directory permissions on the Panzura. So it's very simple, and it's an easy step to making the transition to the cloud. So traditionally, what many people did, and if you had a large office or several offices, you would have storage in each one of those offices, and you had to have enough storage pretty much for everything you had in your company if you wanted everybody to be able to see all that data that you have in the company. You had to replicate it from location to location. You were backing up each location individually, so you were doing a lot of tape backup and a lot of things like that. If you look at a solution with Panzura, each office has what we call a caching controller or a Panzura box, and you're reading and writing data to this, and we're handling the backup to the cloud. We're taking snapshots every 60 seconds. We're handling the global file locking, so nobody in one office is working on a file that somebody else in another office is working on. You're not trying to resolve conflicts or revisions or who has the latest version of it. Like I said, you don't need backup anymore in disaster recovery. There's no more, asking somebody, can you go get this archived project that we worked on 5 years ago off of tape and restore it to the server, and you hope you ask them for the right files, and maybe 2 or 3 days later this gets restored to your server. This is all happening. You see your whole file system all the time, every time. So it's a great solution for even a single office, because you can see your whole file system all the time, even though portions of it are in your local office and portions of it are in your cloud. So when you think about cross-site BIM collaboration, things like, it makes sense, sure, I can work, and I work on a file and it's locked globally so nobody else can work on it. But some of the other benefits are lower cost and resources. Our box only has to be a portion of your whole data set size. If you have 10 terabytes of data, you might have a box in there with 4 or 8 terabytes in the local office, because we only need to cache what you're working on right at that time. But also, when you think about, if we have 3, 4, 5 offices, but somebody in our office is a unique expert at, say, healthcare, and they really do a good job at some aspect of planning your exits out of a healthcare facility or something like that, you can leverage that person very easily, because there's no more flying them in, there's no more posting data and saying, hey, can you look at it? And by the time he gets around to looking at it, it's a week old and you've changed a bunch of stuff. These people are all online, they're looking at the same files you're looking at, and you just ask them to work on it, even though they're in a different location, in a different time zone. Work and collaboration, because you're leveraging your employees much better. We also have what we call a follow the sun model, which means that while the sun's up in any given location, those offices will be able to collaborate very easily. You can still collaborate worldwide, but it's very fast and very efficient. I'll explain a little bit later why we call it the follow the sun model. And so those are some of the additional benefits that not a lot of people think of right away when they're thinking about working in a global environment. So prior to this, people were trying to solve this problem of having to work in decentralized offices, but they're still leveraging projects across multiple offices. And two approaches kind of became popular. One was to centralize, to replicate the files between sites. And so you'd have some very fast, efficient method of, oh, this file's modified, I'll just start a cron job or something that copies the file from location to location to location and try and keep up with it. But that's typically very difficult, and it doesn't stop two people. If somebody's working on a file for an hour, it's very easy for somebody else in another location to go and open that file and start working on it and not realize that somebody else has it open, because each location has its own copy of that file. It's good performance for everybody in that office location, because the data is sitting right there in your office, and it's basically a local area network connection. But it's hard to manage and keep all of that data straight. You're making multiple backup copies. You're not always sure where the most recent version of a file is. The other approach is to centralize all the files. Now that puts one large server on one location, and everybody, across multiple offices is usually remoting in. They're either mapping a network drive across the wide area network off-site, which has poor performance, or you're doing something like VPNing in and getting onto a virtual machine that's right there in the same place as the data. But if you're a long ways away from that virtual machine, your graphics performance is usually a little bit of, there's small hesitation there, and trying to do production drafting work in that environment becomes very frustrating. So then people said, hey, if I just add more bandwidth, or if I add a bandwidth accelerator, then things will get better, and it's just that I can't handle the amount of bandwidth coming through. But the reality is, it's not all about the bandwidth. Bandwidth can be one problem, but once people solve the bandwidth problem, they said, why are things still slow? And the reason things are still slow is latency. So you can think of bandwidth and latency. The two together are a pipe. Bandwidth is really the diameter of the pipe. And the larger the diameter of the pipe, the more data or fluid or whatever you want to go down that pipe, the more you can stuff down all at once. So you have a big diameter pipe, you have a lot of bandwidth, you can push a lot of stuff down that pipe all at once. Latency is the length of the pipe. And it just takes a certain amount of time to go from one end of the pipe to the other. And if it's a very long pipe, it doesn't matter how big the pipe gets. You just can't push data down that pipe any faster than the speed of light, really, in our case. And so latency, when you're talking about thousands of miles, it ends up being milliseconds, but we'll show you in a little bit why those milliseconds add up to being very poor performance. Even if you have a large bandwidth, if it's a long distance, your performance is not going to get better. So what we did was we did an experiment. From this particular experiment was between San Diego and Syracuse, New York, San Diego, California. So you're basically going from corner to corner of the U.S. And it was a small CAD file. It's just 1.5 megabytes. And we did an open on it, and we used some tools to track what happens when you open that file. And what happens is we kind of categorized them into these operations that take to open and lock packets, to close and unlock packets, and to look up packets. You can see there are just thousands of operations of each of these in order to be able to just open the file. And what's really key here is what you read this bottom line here, is that reading the data packets is 1,004 operations, and that took 1.44 minutes. But the whole operation, doing all these other lookups and opens and close and things, took basically 20 minutes. So at the time, if you think about opening a file, it took 20 minutes to do all these operations, and then it took 1.44 minutes to actually transfer the data. And so this is why bandwidth doesn't really help you if you're going a long distance, because no matter how much bandwidth you have, you're going to get through 20 minutes of trying to open a file before you get around to transferring the data. And that's why bandwidth is not the only thing you can look at for a solution. So what happens with Panzura is, because you're not going over the wide area network to open the file, see this user here opens up a file and he connects to a server that's in your local office. And because of that, those 15,000 round trips happen very quickly in very, very 0.28 milliseconds. I mean, that's like it's almost immeasurable. And so what happens is 15,000 calls turn from minutes to seconds, and it really doesn't matter how big the data pack is at that point. It's just like opening a file off of your local drive or off of the local area network. So we took that time down to open that file down to 8 seconds, and really the difference is because we're working across a local area network. We still do some things that have to work across the WAN in order to allow collaboration, but we took those 15,000 calls and dropped them down to a handful of calls in order to handle things that we know we need to handle across a wide area network, and so it becomes much more efficient. We are built from the ground up to handle wide area network connections. Most of your software that's out there nowadays is built from the ground up to work on a local area network. 20, 25, 30 years ago, all that software was built to work on your laptop and not even on a local area network. So it wasn't until networks became popular, servers and networks became popular, that your local area network became the focus of what everybody was building software for. Well, people are still building software to work on that local area network, and we're building the mechanism in the background to allow you to work across the wide area network around the world. So here's an explanation of how we do it. So what happens here is we have 3 locations, New York, London, Sydney. You have a Panzura device in each location. This is a caching controller. It's going to keep what you're working on most often there in your location, so that when you open a file, it's opening it across a local area network. So let's say the person in New York creates a new file and adds it to the global file system. Now, because we are the operating system on that device, the caching controller that you're writing data to, we have the ability to break a file up into data and metadata. You can think of metadata as the information you see when you look in Finder or File Explorer and see the name of the file, the size of the file, the last date it was modified. All that information is metadata on the file. It isn't actually anything that helps the computer read or write data to the file. It's really just a name and a location for that file. We break up the name, all that metadata from the regular data. And the reason we do that is because then that allows us to transfer the metadata up to the cloud. And every 60 seconds, our box is taking what we call a snapshot of all the changes on that box. And we're pushing that up to the cloud. And at the same time, every 60 seconds we push data up there, we're also going up and getting the latest changes from all the other controllers. So all the other controllers are getting our latest changes as well. And so we transfer that metadata down to London, Sydney, anywhere else you have a controller. And now, within 2 minutes, everybody sees the latest change to the file, any new files that are created, things like that. After that, we follow that up by pushing that data, the data for that file, up to the cloud. So it doesn't happen immediately, but it all happens in parallel. It doesn't have to wait for everybody else to see the file or anything like that. As soon as we push the metadata up first so that we can update all the controllers, and then we follow it up with the data, which might take a little bit longer. After that, now everybody else around the world can see this file, and say London wants to open this file. London goes and sees this file on their Explorer, and they click on it. Now the first thing that happens is, to open that file and be able to edit it, they have to get the lock. And so you saw the lock move from New York over to London. That's because to open that file, there's only one lock for any given file. And to be able to open that file in London, they have to go and request that lock from New York. New York says, fine, this person's closed this file, I'll pass you the lock. When we pass the lock over, we also have the latest version of the file embedded in that. And so when the person in London goes to open that file, it knows I don't have the latest version of that file on my computer, on my Panzura, so I need to go get that. And we go up to the cloud and we get the latest version of that, and the file opens. To the end user in London, this is all transparent. For all they know, they went into Word, Excel, AutoCAD, Revit, whatever the application is. They went to File Open, and they saw that file, that new file in the location it was saved in. They opened it, and it just opened on their screen. The difference is that if it's something like Word, Excel, PowerPoint, something like that, a lightweight file that's, say, under 10 megabytes or so, that's going to happen so fast, transparently, the end user isn't going to notice that that file took another 1 to 2 seconds to open. Larger files like AutoCAD, Revit, where you get to tens of megabytes, hundreds of megabytes, we have ways of pre-caching that data if you need it, and then opening that file so that it's already there and we don't have to go get it. But in a nutshell, that's basically how we work and how we handle global file locking, so that multiple users don't end up editing the same file. If the user in London went and tried to open that file, and the user in New York, say, had saved it so the user in London could see it, but hadn't closed it, the user in London would get a message that just says, this file is currently locked by another user, the name of the user, and do you want to open this file read-only? It's basically the exact same message they would get on a local area network if they tried to open a drive on the network that was opened by, locked by somebody else. So it's that smooth. It just basically makes your whole global organization act as if it's one local area network. And it uses the cloud for backend storage. So now that's kind of the simple scenario where you open a file, it locks, and it works. Revit's a whole different animal because I'm sure those of you who use Revit know that Revit allows multiple people in the same file at the same time. Again, Revit was originally built to work on a local area network. And so it's still designed and works on that basic premise. Even with solutions like Revit Server, it's basically still doing the same operations and same things. The problems we looked at originally for Revit were problems like trying to share Revit in an environment where people are working across a local area network or a wide area network. You would have things like Florida to New York has typically 60 milliseconds of latency. And things like just trying to do a sync to central would take 15 to 20 minutes. When it takes that long to do a sync with central, Revit starts to report failures and says either the model's corrupt or it's unable to save the file. Even though the model isn't really corrupt, it's just that it's taking so long, Revit gives up. And so the effect is that you end up with a terrible user experience when you're trying to use Revit across a wide area network. In our solution, what's happening with Revit is, for Revit, although it wants you to believe that multiple people are editing the same file at the same time, what you're actually doing is creating a local copy. You'll always notice that checkbox at the bottom of the file open box says create new local. And whenever you open a centrally shared model, work shared model, and you create a new local copy, it copies it down to your laptop or desktop. You're working on that RVT file there on your desktop. What it's doing, though, is it's very subtly going into the backup folder for that central model. And every time you move objects, you check something out, you check out a work set, you check out an element, it's reading and writing small amounts of data into that backup folder. Now, if we were to say, okay, every 60 seconds we're going to take a snapshot of the changes in the model and push that up to the cloud, and then every 60 seconds the other devices were to pull that data down, that would be 2 minutes roughly before the backup, the changes in the backup folder were replicated across multiple sites. And that's just way too long for Revit to be able to work efficiently, and you'd be able to work inside of Revit with multiple people in the same model in 2 different locations. So our device has something called change notification on it, and so when you open a Revit model, and inherently when you open the Revit model, you're opening up files in that backup folder. We're registering all those files for what we call change notification. And those change notifications are getting registered when 2 people open in 2 different locations open the same model. The backup folder in those 2 locations are both registering for change notifications. So basically those 2 devices know, oh, we have 2 people working in the same model at the same time. I need to let the other device know when my file changes, and that includes everything in the backup folder. And so every time you move objects and you do things inside of Revit where it writes to that backup folder, we're very quickly syncing those messages over to the other box. We don't bother going up to the cloud and back down to that box. Our devices all know about each other, and so when 2 devices have the same model open at the same time and they're working, those changes that are happening in that backup folder are just getting synced straight across the network from box to box. And so we can handle Revit working in just about across any continent is the way I like to think of it. It's up to about 90 to 100 milliseconds, and it works very smooth in a production environment. And And so the way you can think about that is basically in the U.S. it's coast to coast. It's it's most of Europe end to end. It's most of Asia from end to end. Australia is about the same from coast to coast in Australia. So that's about how much we can handle simultaneously in the same file. So going back to latency, that becomes a problem for latency. It really doesn't matter how big your bandwidth is. Well, it does, because you have to have enough bandwidth to handle the data going across your network. But really the limiting factor, we can't beat latency. So if you want to collaborate in the same model at the same time with, say, China, and you're in the US, you're looking at 200, 250 milliseconds of latency. And there's just no solution that's going to provide you the ability to do that in a production environment very effectively. It's just purely physics and distance. So the reason the follow the sun model works well for us is because as the US is going to sleep, China is waking up, then India, then Europe, and across the world. As the sun moves over there and they wake up and start work, we're typically going to sleep. And what happens is those locks and all those changes are already there by the time they wake up. They start work, they do their work, and by the time the sun comes back around to you again, people around the world could have been working on your model, and you go to open that and you know you have the latest version, the most up-to-date version of everything that's been done. You don't need to check your email. You don't have to go up to some centrally located server and download those files and things like that. It's all just happening for you in the background. A couple other things about Revit, Work Sharing Monitor, because we have a solution where you're actually working on a local area network and we're keeping things synced around the world. We're one of the only solutions out there that can support Work Sharing Monitor. Even Revit Server does not support Work Sharing Monitor. We handle element borrowing. At the borrowing elements at the element level, you can just grab objects, move them, and all that same behavior you would see on a local area network will work just fine in our solution. So I believe this is another slide, shows you the vast array of people that are using our systems. There's some of the largest companies in the world down to some of the smallest. We have single site locations using us as well as very large locations.